All right, in this explainer, we're going to take a peek under the hood of the device you are almost certainly using right now. Ever stop to think what's actually happening when you click or type or swipe? Well, let's find out what makes it all tick.
I mean, we use these things every single day, but at the end of the day, they're basically just a box of circuits and code. So how does all of that come together to work so flawlessly? That very question is really the perfect starting point for understanding this complex machine right in front of us.
Okay, so let's start with the absolute basics. The key here is to stop thinking of your computer as just one single thing, but as a computer system. So what exactly does that mean?
At its core, a computer system is really a team. It's a collection of different parts, and each part has a very specific job to do, but they're all working together toward one single goal: to receive, process, and give us back information. And it turns out, every single computer system, from the phone in your pocket to the biggest, most powerful supercomputer, is built on three fundamental pillars. So let's break down each one.
All right, let's kick things off with that first pillar, hardware. This is everything you can physically see and touch. It's the tangible foundation of the whole system.
You know, if you think of the computer system as a person, the hardware is definitely the body. It's the collection of all the circuits, the chips, the wires, and all the devices that create the physical structure for everything else to happen. Now, what's really cool is that all the incredibly complex things a computer's hardware does can actually be simplified into 4 basic steps. It's this continuous cycle: input, then processing, then output, and finally storage. Let's take a quick look at each one.
So everything has to start with input. This is how we communicate with the computer, how we give it data to work with. Every single press on your keyboard, every click of the mouse, or even a voice command, that's all input, sending signals into the system. Okay, so once the computer has done its job and processed the information, it needs a way to talk back to us, right? To show us the results. Well, that's the job of the output devices. They translate all that digital data into something we can actually see on a screen, hear from a speaker, or even hold in our hands from a printer.
But hang on, what about that thinking part, the processing? All of that magic happens inside the central processing unit, or as you've probably heard it called, the CPU. Seriously, you should think of it as the brain of the computer. It's the engine that does all the heavy lifting and all the calculations. And if we could zoom right inside that CPU, we'd find 2 main components running the show. First, you've got the control unit, which acts kind of like a traffic director, managing where all the data is flowing. And then you have the arithmetic and logic unit, which is the mathematician of the group. It's the part that handles all the calculations and logical decisions. And that brings us to the final step in the hardware cycle: storage. I mean, after data gets processed, it needs a place to be kept, right? But here's the thing. There are 2 very different kinds of storage humming away inside your computer.
And this chart shows the difference perfectly. You've got primary memory, or RAM, which is a lot like your brain's short-term memory. It's incredibly fast, but it's also temporary. As soon as the power goes off, whatever was in it is gone. Boof. Then there's secondary storage, like a hard drive. That's the long-term memory. It's like a permanent library that holds on to all your files, even when the computer is turned off.
So we have the physical body of the computer, the hardware. But a body can't really do anything without a mind to give it instructions. And that brings us to our second pillar, software. Yeah, if hardware is the body, then software is definitely the mind. It's the set of instructions, the programs and applications that tells the hardware what to do. Think about it. Without software, your computer is just an expensive paperweight. It's the software that transforms that hunk of metal and plastic into a web browser or a video editor or a music player.
Okay, so we've got the hardware body and the software mind.
But there's one final, absolutely essential piece of the puzzle that makes the whole system actually, work.
It's called liveware, or sometimes you'll hear it called humanware. And in the simplest terms, it's you, the user. The person interacting with the technology is what gives the entire system its purpose and its direction.
And this right here is the key takeaway. The liveware is the ultimate commander of the system. The hardware and software are incredibly powerful tools, for sure, but they're also passive. They just wait for your instructions.
And that's the vital role that you play. Without the liveware, the hardware and software are totally purposeless. You're the one who decides what tasks need to be performed, what to create, and which problems to solve. And that right there completes the picture.
You've got the three pillars: the physical hardware, the instructional software, and the directing liveware, all working together. It's this synergy that creates the powerful and seamless computer systems that are so important to our world.
This all brings us to one final, pretty thought-provoking question. As our hardware gets faster and our software, especially things like AI, becomes more and more intelligent, how is the relationship between these three pillars going to change? What will our role as a liveware look like in the future?